In this video, I'm going to go through two different methods for determining the acceleration due to gravity g by free fall methods. Okay, the first one involves an electromagnet and a ball being released by the electromagnet and timing how long it takes to hit the trigger pad. The second one involves dropping an object through two light gates and looking at the speed of the object through the first and second light gate. I'll also be looking at a variation which only involves using one light gate. In my class, you'll be testing the following CPACs. 2A, that you can set up the light gate, the electromagnet, the timer, and the data logger correctly using the correct setting. 2B, that you can change the height the object is falling through and that you're able to ensure that it falls onto the trigger pad correctly or that it goes through the light beams correctly as well. 2C, that you account for other variables like air resistance and the effect that it could have on it, and you also discuss how you're going to reduce the percentage uncertainty in your readings. And finally, 5B, that you do some online research into what the value for gravitational field strength should be in your city, and also you look into other methods which you can use to determine G possibly more accurately. You're going to have to reference the website or the book that you use to determine these, and you're going to look at how to reference correctly as well in your report. I'm going to summarize the two methods that you'll be using. First one is the electromagnet and the trigger pad. The ball is going to get released and it's going to fall on the trigger pad, and the timer is going to give you the time it takes to do that. You're going to change the height the ball is dropping by, so maybe you can move the electromagnet downwards, and you're going to change the height and you're going to measure the time it takes for each of those height to fall on the trigger pad. Ultimately, what you want is you want to put a straight line with the data you get. So the equation that you're going to use in this example is s equals ut plus half at squared. But because the initial velocity is 0, the electromagnet is going to release the steel ball from rest, then that means it just simplifies to s equals half at squared. On the y-axis, we can plot s in meters, and on the x-axis, you can plot time squared. We shouldn't be having a y-intercept. If there's some kind of error, then you might get a small y-intercept. Okay, then based on this, we should be getting a straight line going through the origin. Okay, and the gradient is the thing that's going to multiply the time squared, which is half times acceleration. And the acceleration here is going to hopefully be the acceleration due to gravity, hopefully 9.81. Okay, so we know the gradient is half a, so therefore the acceleration due to gravity is going to be gradient times 2 in this method. Method 2 involves using light gates. You can either use 1 or 2 light gates. I'm going to go through the method using 2 light gates first. So we're again changing the height that the object is falling through. And in this example, we're going to let it fall through the 2 light gates. And we're going to measure, the data log is going to give the time it spends going through light gate 1 and time it spends going through light gate 2. And using the length of the card, or the dowel in this case, 4 centimeters, you can find the initial and final velocity. Again, we're going to try to put a straight line, y equals mx plus c, but now we're going to use this equation, b squared minus u squared equals 2as. And because both v and u are variables that we're determining, we're going to plot v squared minus u squared on the y-axis. And on the x-axis, we're going to plot s. So that means the thing that's multiplying this displacement is 2a. Okay, so you should be getting a straight line, and the gradient is going to equal 2 times the acceleration due to gravity. There shouldn't be any y-intercept in this example. Okay, so that means the gradient is 2a, so gradient divided by 2 should give you the acceleration due to gravity. Now, it is possible to do this method just using one light gate, but you need to make sure that the initial velocity of the object is equal to 0. So it needs to be released from rest, not going up or down, just needs to be falling from rest. So you need to have some method to do that. You're going to change the height that's falling by each time you take a measurement, and make sure you measure the height from the center of the object to where the light beam is in the light gate there. Okay, so let it fall through, and you'll get the final velocity by dividing the length of the object by the time it spends going through light gate 1. Once again, we're trying to get a straight line, but now we don't have to worry about the u squared because that's 0, it doesn't have an initial speed, and the gradient should still equal 2 times acceleration, so gradient divided by 2, it should give you the gravitational field strength. Now that you know the methods, you'll need some tables to record your results. The electromagnet method is pretty straightforward. You're going to change the height and you're going to take time readings at least 3 times per height and then find the average. The table for the light gate method is a bit more complicated. So in my example, I actually use the card which is 8.6 centimeters in length. So make sure you write that down because you'll be using that length of the card along with the time it takes through the light gates to find the initial speeds and the final speeds. Here's an example of a table that you can use. Now remember, if you are setting the initial velocity equals 0, you won't need these columns. Okay, so you're just worrying about the final velocity, and that's a much simpler method. But if you are taking the initial velocity as well, then you need this whole set of data. Here's an example of the data that I have. As you can see, I'm changing the height. For each height, I have 3 readings of time for the first light gate because I've repeated it 3 times for each height. Okay, so take this, average it, find the average time to go through the first light gate, divide the length of the card by the average time to get the initial velocity through the first light gate. Repeat this again for the final velocity, which is the time it takes to go through the second light gate and the length divided by that time, and that'll give you the final velocity. And as you can see, it's accelerated and is going faster to the second light gate. Finally, you can do v squared minus u squared and write that down as well, because you can use that to plot a graph later on. In order to pass your CPACs, especially 2A, 2B, and 2C, you'll have to write a couple of things down in your discussion section, talking about what you did during the practical. So first thing you need to discuss is what kind of setting you used for the timer and the data logger. So for example, the timer, you would get it to start when the electromagnet releases the ball, and it'll stop when it hits the trigger pad. And with the data logger on the light gate, you'll get it to measure the time it takes for the dowel to go through, and you'll have to use the length of the dowel, as an example. Another thing to discuss is how you ensure that the object falls vertically through the light beams in the light gate or onto the trigger pad. So an example of how you could have done this is using a plumb line like so. A plumb line forms a perfect vertical line, and you can use that to make sure that the object falls directly through the light beam. And you can discuss that in your discussion section. Okay, you should discuss how you measured the height of that the object is dropping by accurately. So get a ruler, but you need to make sure the ruler is vertical. So you can use a set square like this, aligning it with the horizontal table and the other side with a vertical ruler to make sure it's perfectly vertical. And then again, using set square, you can measure to the bottom of the ball like this and write down that reading. And to the top of the trigger pad, write down that reading. And if you subtract those 2 readings, then you will get the height that the ball drops by. Finally, you want to discuss how you decided on the range of heights to use during this practical. So you can't use really large heights. So for example, you can't use heights larger than 1 meter, because in that case, the ball is going to accelerate to a higher velocity, and that means there's going to be more air resistance on it. And if there's more air resistance, that's going to affect the acceleration due to gravity that you will determine later on in the practical. So you can't use very large heights. But at the same time, you can't use very small heights to drop the ball by, because you're measuring the height with a ruler. And if you're measuring something that's very small, like small height, then you're going to have a bigger percentage uncertainty in that measurement. So we want to avoid very small heights, and we want to avoid very large heights. The step 4 is to analyze the results. So from these 2 practicals, pick out the one that you think is going to give you the best results for G. So the one that's going to be closest to 9.81. Plot the graphs, and you can plot that on paper or you can plot on Excel, whichever, and use the gradients to find G, and we're going to use this in the next section. Finally, you need to do some online research. So first thing you should look up is the value for G that you expect in your city. So for example, in London, I expect 9.812 according to this website here. In my discussion section, I'll write down, here's the value for G that I measured, and here's what this website expects me to get. And in square brackets, I'll write down number 1. And then in the reference section, I'll put the URL to the website I got this number from, 9.812, and then I'll write down the date I accessed this website. Another set of research you want to do is onto other methods that you could have used to determine acceleration due to gravity. So for example, on YouTube, I found this video which goes through a different method, and then in my discussion section, I'll write down another method I could have used involved allowing a ball to roll down a ramp. This method might be better because so and so. You need to elaborate onto the method and why that's good. And as you can see, I wrote down square brackets 2, and again, in the reference section, I'm going to give a link, the URL to that YouTube video, and I'm going to write down the date that I accessed that YouTube video.